Hello, everyone. Welcome to Math Made Simple by Professor Burnett, your go to place for clear and straightforward math explanations. For my MAC 1105 college algebra class, I will be reviewing key math concepts in a way that's easy to follow, helping my students gain confidence in their coursework. This lesson will cover section 4.6 polynomial inequalities. So let's get started. Problem 1, solve the given polynomial inequality. Report the solution in both interval notation and graphical form. Interval notation and graphical form. So here we go. We have the quantity x plus 6 times the quantity x plus 2 is less than 0. First of all, this is a less than symbol. Does not have equal to, so we don't have the option of being equal to. So the end of the notation will be open. Also, numbers that are less than 0 are negative numbers. So let's find out our critical values. So we're going to find our critical values by setting each quantity equal to 0. This is the zero product property. Anytime you have two factors multiplied together and the product is 0, one or both of those factors must have been 0. So to solve, we are going to isolate x. So the opposite operation, subtract 6 from both sides, subtract 2 from both sides, and we get x equals negative 6 or x equals negative 2. And we can plug that back in and check. Now those are just our critical values. So we're going to draw a number line and we're going to place these numbers in order from least to greatest. And we're going to graph the endpoints of these critical values. Again, there is no equal option, so the endpoints will be open. Okay, and if you're using this notation, at this point, I'd rather use the open circles because I don't know which region I'm going to result in. So as a result, I don't know which way to turn my parentheses. So I'm going to stick with the zeros right now, or the open circles. So now we have graphed our number line. We have listed our critical values on the number line, and we've included open endpoints. Now, we need to test these intervals, these three intervals created by these two critical values. And so we go back to the fact that x plus 6, the quantity x plus 6, times the quantity x plus 2 is less than 0. And we plug in test values. We're not allowed to plug in negative 6 or 2 because we already know what happens. It gets us to 0. So we're going to test points in each one of those intervals. 0 is an easy one. The very next one here is negative 1. And over here, negative 7. So when we plug those in back into the original equation, we're going to get a negative 7 plus 6 in the first quantity. And that's going to give us negative 1. And I'm only interested in the sign rule at this point. Plug in negative 7 into the second quantity, and I get negative 5. That's a negative. So a negative times a negative, that's going to give me a positive for this region. Testing my middle region, plugging in 0. 0 plus 6 is 6. 0 plus 2 is 2. Both positives. Positive times a positive is going to be positive. And let's go back. Zero does not belong here. 0 actually belongs in this interval, and -3 belongs here. So plugging in a -3, I get a positive and a negative. Positive times a negative, the middle region is negative. And these signs generally alternate. So I'm expecting the last region to be positive. So let's try it out. 0 plus 6 is positive. 0 plus 2 is positive. So this last section indeed is positive. But what I'm looking for are regions that are negative, and that would be the middle section. So this is what I shade in. So this is not what I shade in. The positive regions, actually it is. I was looking for negative, and that's that middle region. So interval notation would give us from -6 to -2 open intervals, as indicated by the parentheses. And we already have the graphical notation as well. Okay. So if you wanted to use parentheses at this point, you could. Open parentheses, and the middle region. Okay. Now let's test and see how our video is turning out.